Hello friends, welcome back to my channel Engineering Mathematics djganit. From this lecture onwards, we are going to discuss graph theory, which is important topic of the subject discrete mathematics. In this lecture, we will understand basic terminology of graph theory and we will extend different concepts of graph theory in upcoming lectures. So first we understand what is the meaning of graph. So whenever we are discussing graph theory in discrete mathematics, the graph does not mean that graph of a function. For example, we have understood in our school that suppose we have the function fx equal to x square, then we say that this is the graph of the function fx equal to x square. But here the graph means not this type of graph which we have understood in our school level. Here the concept of graph is one type of diagram. For example, suppose I consider this diagram. Suppose I am considering these three circles and I am joining these two circles by a line. Then this diagram is an example of a graph. So graph means we have certain points which we denote by dots or circles, and some circles or some points are connected by line or by arc. It is not necessary that we should use the straight line segment to join these two points. We can use any type of arc also. If we wish, we can draw this type of arc also. So we are not concerned about the geometry of line or arcs, but the meaning of graph is we have two sets. One set is the set of points or circles which represents the objects, and these points or circles are called nodes or vertices. So we have one set which is the set of nodes, and in this diagram certain pair of nodes are connected by line or arc. So those line or arcs which connect nodes are called edges. So we have in the definition of graph, we have one set which is the set of vertices or nodes that we denote by capital V, and we have another set of edges, that is the lines or arcs which connect the given pair of nodes. So if we have these two sets, that is set of vertices denoted by capital V and set of edges denoted by capital E, and if to every member of the set of edges, to each edge in this set E, there corresponds a pair of nodes, then we can say that this diagram is a graph. So graph is defined as the algebraic system in which we have set of vertices denoted by V, set of edges denoted by capital E, and there is a function denoted by phi from the set of edges to the set of vertices. Phi is a mapping or function from the set of edges denoted by capital E to the set of vertices. That means to every edge denoted by small x in this set, we have an ordered pair associated from this set of vertices. So remember this definition of graph. They ask the definition also. A graph G equal to ordered pair V comma E and with function denoted by phi consists of a non-empty set V, which we call the set of nodes or points of the graph, and this capital E is said to be the set of edges of the graph, and phi is a mapping from the set of edges E to a set of ordered or unordered pair of elements of V. That means phi is not a function from E to V, but phi is a function from set of edges to the Cartesian product of V with itself. To each edge in the set of edges, there must have a pair of vertices. So if these vertices are ordered, if order is important, then we will use this notation. This is for order important, so this we use for ordered pair, and this notation is for unordered pair. So phi is a mapping from the set of edges capital E to the Cartesian product of set of vertices with itself. So if we have this situation, then we have a graph. So this is the definition of graph. A graph G equal to VE phi consists of a non-empty set capital V called the set of nodes, set of edges denoted by capital E, and phi is a mapping from the set of edges E to the set of ordered or unordered pairs of elements of V. That means it is a mapping from capital E to V cross V. Here I have taken several diagrams which are satisfying this definition, and therefore they are the examples of graph. In first part, denoted by part A, I have two vertices denoted by V1 and V2, and we can see that they are not connected by any line or arc. So there is no edge here, so we can denote this graph by G equal to set of vertices, that is V1 comma V2, and set of edges is empty set, there is no edge joining V1 and V2. Here we have an arc joining V1 and V2, and this arrow indicates that there is an arc or edge from vertex V1 to vertex V2. So if direction is specified, then we can say that our edge is an directed edge. So if we have arrow pointing towards the another node, then the edge is called directed edge. So here this is also an example of graph in which we have set of vertices. V is having two elements V1 and V2, and we have one edge. Suppose I denote this edge by X, then in the set of edges we have element set containing edge X. This is also an example of graph, but here arrow is not given. That means this is an undirected edge. Similarly, I have written these three graphs. Here we have three vertices. So set of vertices V contains three objects denoted by 1, 2 and 3, and we can see that this 1 and 2, there is an edge from 2 to 1, so that we denote by ordered pair also. 2, 1, there is an edge from 2 to 3, that we denote by 2, 3, and here edge is undirected, so we write ordered pair 1, 3. If we have unordered pair, then we use this bracket. For ordered pair, we will use this bracket. This is another example in which all the edges are directed edges. This is another example in which all the edges are undirected. Here all the edges are directed. So these are the several examples of graphs. So all we have to understand is a graph is an algebraic system in which we have set of vertices, set of edges, and there is a mapping from the set of edges capital E to the Cartesian product of V with itself. This means to every element in the set of edges or corresponding to each edge X in the set of edges, there corresponds an ordered or unordered pair, either UV or UV, from this set. If this happens, then we say that this system GVE phi is a graph. So we will be continue in this discussion with different terminologies, and we have to remember all these definitions and terminology that we will require throughout this chapter. Here we have written that if an edge X belongs to E is associated with an ordered pair or an odd ordered pair where UV belongs to capital V, then we say that the edge X connects or joins the nodes U and V. That means if I have two vertices and if I have a line or edge joining U and V, either directed or undirected, then in the language of graph theory we will say that this edge X joins the vertices U and V. Any pair of nodes which are connected by an edge in a graph is called adjacent nodes. So if two vertices are connected or joined by an edge, then we say that they are adjacent nodes or vertices. For example, suppose I have this graph and suppose I have this type of situation. Suppose I denote these vertices by V1, V2, V3 and V4. Here we can see that this V1 and V2 are connected by an edge, say X1. Then we can say that V1 and V2 are adjacent. Similarly, suppose X2 is an edge between V2 and V3. That is, X2 connects V2 and V3. Therefore, V2 and V3 are adjacent vertices or adjacent nodes. V1 and V4 are not adjacent because they are not connected by any edge. Similarly, V3 and V4 are not adjacent because they are not connected by any edge. So that is the meaning of adjacent nodes or vertices. Similarly, as I discussed, we can define directed and undirected edge. In a graph G equal to VE, instead of denoting our graph by this notation VE and phi, we can simply use this notation, or we can simply use capital G also. In a graph G equal to V, E, an edge which is associated with an ordered pair of V cross V is called a directed edge of G, while an edge which is associated with an unordered pair of nodes is called an undirected edge. That is, if we consider the direction in the edge, then this edge X is called directed edge, and if there is no direction specified, then we say that edge is undirected. So here order is not important. We can say that X is an edge from U to V, or X is an edge from V to U. So in this case, this edge X is undirected, and that we denote by this type of unordered pair. Here arrow is specified from U to V, therefore here direction matters. We can say that X is an edge from U to V. We cannot say that there is an edge from V to U. So this is directed edge. So that is meaning of directed and undirected edge. Now a graph in which every edge is directed is called a directed graph, or in short we say that it is a diagraph. So directed graph means every edge of the graph is directed, and undirected graph is opposite of directed graph. A graph in which every edge is undirected is called an undirected graph. And if some edges are directed and some are undirected in a graph, then graph is called a mixed graph. So here we can say that we can decide which graphs are directed and undirected. For graph in this part, there is no edge joining V1 and V2. There are only two vertices and we don't have any edge connecting V1 and V2. So we can consider this as directed graph as well as undirected graph. Here we can see that this edge X is associated with ordered pair V1, V2. Therefore, this graph is directed graph. There is only one edge and it is directed. Here this edge is undirected, therefore this graph is also undirected graph. Here in part D, we can say that there is an edge from 2 to 1. This is directed edge. This is also directed edge, but this is undirected edge. Therefore, we have mixture of directed and undirected edges. Therefore, this graph is mixed graph. Here all the edges are directed. Therefore, this is directed graph, or we can shortly write diagraph. Here all the edges are undirected. So this is an example of undirected graph. This is an example of directed graph. Every edge in this graph is directed. So remember all these definitions. We will be having their use in upcoming lectures. Similarly, we can talk about these other things, that suppose I have a graph denoted by V, E. Suppose X is an edge of the graph which is directed edge associated with the ordered pair of nodes UV. That is, we have directed edge from U to V. So in that case, this edge X is said to be originating or initiating from the node U and ending in the node V. Okay, this is very common thing, but we should understand in the language of graph theory. If X is an edge connecting U and V, and if it is directed edge, then the edge X is said to be initiating or originating in the node U and terminating or ending in the node V. And we call node U as initial node and node V is called terminal node. That I have written here. U is initial and V is terminal node of the edge X. An edge X belongs to E which joins the nodes U and V, whether it be directed or undirected, is said to be incident to the nodes U and V. If there is an edge between two vertices, then that edge X is said to be incident to the nodes U and V. So in this way we will be discussing these different concepts of graph theory in upcoming lectures. In this lecture we have discussed what is the definition of graph. That is, we have a diagram in which we have set of vertices, set of edges, and mapping phi from this set of edges to V cross V. Then we say that algebraic system or diagram is a graph. Now there are several pictorial representations for the same graph. For example, if I have two nodes or vertices, then I can join them by this type of straight line. If I wish, I can join them by this type of any edge. So we are not worried about the shape of the arc joining two vertices. Similarly, we can have this type of things also. Suppose I have this graph. Now instead of this, we can use another type of representation. also we can use any of this type of pictorial representations for the same graph. So sometimes it happens that two pictures are totally different, but they represent the same algebraic system which we call as graph. So there are infinite number of representations for the same graph, so that we have to note down. And we have understood the definition of directed graph and undirected graph. A graph in which every edge is directed is called directed graph. A graph in which every edge is undirected is called undirected graph. And if we have mixture of directed and undirected edges, then graph is called mixed graph. Similarly, if we have an edge connecting different nodes, suppose U and V are connected by an edge, then we say that U and V are adjacent nodes. Similarly, we have an arc between V and W, so V and W are also adjacent nodes. Another terminology is, if we have an edge X connecting U and V, then we say that X is incident to U and V, or U and V are adjacent nodes. So these are different terminologies. If we have directed edge from U to V, then we say that edge is originating from node U and terminating or ending in the node V. So remember all this terminology, that will be useful for upcoming lectures. And this is all about this session. I hope you like it. Thanks for